Evaluate the limit. The limit of the quantity 1 minus cosine squared of 4x divided by sine squared of 3x as x approaches 0. Let's start by using some trig identities to rewrite the function before taking the limit. The first one that I see is 1 minus cosine squared of 4x. Well, because of the Pythagorean identity, sine squared 4x plus cosine squared of 4x is equal to 1, and then the subtraction of cosine squared of 4x to both sides, we can replace 1 minus cosine squared of 4x with sine squared of 4x. And then in the denominator, we still have sine squared of 3x. The next thing that we're going to do is we're going to multiply both the top and bottom by 1 over x squared. And the reason that we're doing that is we're trying to get sine of whatever x over x format. And because sine is squared, we have to make the x squared in the denominator also be the same. So that will make our expression become sine squared of 4x divided by x squared all over sine squared of 3x divided by x squared. The next thing that we are going to do is we're going to work on getting the coefficients in the denominators being equal to the square of the angle. And the reason that we're doing that is because we're going to have sine squared over that quantity with the x squared. So then you can write sine of ax over ax quantity squared. So that's going to be the next step here. So we're going to multiply the numerator by 16 over 16 and the denominator by 9 over 9. And the reason why I'm doing the squares is because we're going to have to rewrite these sine rational expressions to the second power, and 3 squared is 9 and 4 squared is 16. So let's use this information to rewrite it. So we have 16 times sine squared of 4x divided by 16x squared, which is equal to 4x quantity squared, over 9 sine squared 3x divided by 9x squared, which is equal to 3x quantity squared. So the next step is going to be writing both our top and bottom fractions as 16 and 9, like bring them out. And then in the parentheses, we're going to have sine of 4x over 4x quantity squared. And in the bottom, we are going to have 9 times the sine of 3x over 3x quantity squared. And then, since the sine of ax over ax is equal to 1, and 1 squared is 1, we can cancel these fractions out. And now we have something that we can take the limit of. So we can take the limit of 16 over 9 as x approaches 0, which is equal to 16 ninths, or answer choice B.